Hello, today we continue to look at gases and parameters related to gases, and we will continue today to talk about the density of a gas. Recall that in the previous lesson, you and I derived a formula that applies to a gas, and this in turn is related to the mass, to pressure, the universal gas constant, and temperature. This formula is used for calculations related to both the paint mass of gases and in turn to pressure and temperature. But you know, it is very often customary for gases to compare them with each other. But besides this value, sometimes another kind of density is used when gases are compared with each other. And then such a density is called the relative density of one gas in relation to another gas. It is usually denoted by the capital letter D, and it's a ratio. In this case, the molecular weights, the molecular mass of some unknown or known gas X in relation to the molecular weight of a known gas Y, or we can take this ratio of the molar mass of gas X to the molar mass of gas Y. This value plays a purely practical role because depending on what the density is, it can be related to how this gas will be collected. That is, how you have to place, for example, a vessel or a balloon in order to fit this gas into it compared to, for example, air. Let us give examples of calculations. Let's say we need to calculate the density of carbon dioxide, the gas that we breathe out, for example, relative to hydrogen gas. So let's do the calculation. Carbon dioxide weighs in at 44. It's not hard to calculate that. Carbon 12, oxygen 16 times 2. And that's relative to hydrogen times 2. And then we can say that we have carbon dioxide is 22 times heavier than hydrogen. So it turns out that if the density exceeds 1, and in this case it exceeds 1 many times, then we can say that CO2 has a mass greater than hydrogen, and therefore it is a heavier gas. Now let's do a calculation, for example, in this case. Let's take it in relation to oxygen and compare oxygen to, say, helium gas. Compare the two gases. So for oxygen, it's 32. And helium, we can find a mass of 4. And then it turns out that this density is equal to 8. And 8 is also more than 1. So it turns out that oxygen is heavier than helium. But because we're in an airy environment, gases are often compared to air. But the thing is that air, as you probably know, is a mixture and it's a mixture of several gases. First of all, there's nitrogen, and nitrogen is the most abundant in air. There's oxygen. Carbon dioxide is included. It's not very much carbon dioxide. It's mostly nitrogen and oxygen. Inert gases are included. For example, argon is included, and others. So we can't calculate the molecular weight of air in the usual way, as we did for CO2 and oxygen, for example. Then we have to remember that the molecular weight of air is a value which was calculated with the help of special methods, and it is equal to 29. And then compare gases with this value, and what conclusions will be made when comparing gases with air, we will see now. Let's calculate the density of hydrogen gas in relation to air. So hydrogen weighs 2. The air weighs 29, in which case we have a value of 0.0.0 6.9, as we understand it, the density is less than 1, so hydrogen is lighter than air. And then how to collect this gas? Schematically, we can show it in the following way. Then hydrogen gas is collected in a vessel, which should be with the bottom up. That's why balloons, when they are inflated with hydrogen, they rise up. It had a purely practical application in its time, because not only balloons were inflated with hydrogen, but for example, airships. However, hydrogen is a very explosive gas, and so this idea, after a series of accidents, for example, airship Gezenberg, then abandoned, and now hydrogen to fill airships' balloons are not used. Helium is used, and helium has a mass of 4, and even it is not difficult to calculate that the density of helium in relation to air will be respectively less than 1. So now for these purposes used helium. And now let's calculate, let's say, what is the density of oxygen gas, which we, on the contrary, inhale together with air in relation to air. So that would be 32 to 29. And then we have that this value will be about 1/10. It turns out that the density of oxygen in relation to air, we have more than 1 unit, and since it is more than 1 unit, then oxygen should be collected in a vessel located with the bottom down. So if we filled the ball, for example, with oxygen, this ball would not rise to the top. So the density is used, for example, as a practical component of experiments when you need to collect certain gases. Using density, you can find, for example, the molecular mass of an unknown gas. So let me tell you that, for example, some unknown gas. Relative to air will have a density of 2. Let's calculate how much our unknown gas weighs. Then we convert this formula, and what we get is if the molecular weight of the unknown gas is x, so we'll need to multiply the molecular weight of the air. And multiplied by the d of this substance, x by, in this case, y, where y is our air. And then it turns out that we have 29 times 2, so the unknown gas weighs 58. As you can see, these calculations are not complicated. They are much simpler than, for example, the density, which is calculated with the help, including gas laws. But this density plays a purely practical application, so it is used necessarily in the practical purposes of chemistry. I hope that's clear. Goodbye.